Yeah, good evening. The earlier video just some technical problem. It has got abruptly ended. Yeah, we'll continue that presentation. We are now talking about underground pipeline irrigation system. Uh, Let me minimize this and then go for our presentation. Now we have seen this pump stand already discussion, and then now gravity inlet. So this is one thing which is required. Suppose you are drawing water from a uh, channel. So channel means channel water means not from borewell but from a irrigation channel which is having a surface channel. This is a sectional view of inlet taking water from a channel into an underground pipeline system. So you must have a desilting tank before it is going underground. Suppose this is a ground level. Okay. Now you are making this water to enter in this chamber. That's how a gravity inlet, by gravity flow only. Now before that, here you will have a not shown here but desilting tank, and then a trash screen also. There are some leaves and other light material which should not enter into the pipeline system. So this is the channel banks, these two, and at bottom of the channel the water flows into it. A clear water must flow into this is the pipe, underground pipe. Okay, this is what gravity inlet, which we are emphasizing because many times we try to use this surface water also for underground pipeline system. And then this is a gate stand. We were discussing these some of these elements. They are purposefully placed at certain places. What for this gate stand? First of all, you can see this is sectional isometric view. It has got control wheel, then end support, then concrete pipe. This is a ground level. This is the underground pipeline, and from which these gates operates. Gate frame. This is a gate frame. This is the inlet, and this is the outlet. Of course, this is a concrete base. Gate stands are provided to control the flow into the laterals. Suppose you are taking one lateral. You are taking one lateral away from this, like this. Then you should provide this gate stand so that you can turn that water into that lateral. That is diverting that water into the lateral. So into the when pipeline branch off in different directions, not only one direction but different directions. They also prevent high pressures and act as a surge chambers. In fact, like air vent also it will act. They are made in the same way as pump stands basically, but are provided with slide gates or valves to control flow into the lateral pipeline. These are the valves, and they will turn this, and the sideways or laterals the water will flow. So they may take off any desired direction. The gates are provided with handles, which permit their operation from top of the structure. So this is the pipe underground, and simply at the top only it is you can see completely on the surface. You can see you can operate from the land on the top of the surface. Okay. Then air vents. So we have got a separate slide exclusively text matter for this because there are certain things, points to be remembered. First of all, what are air vents? Air vents are vertical pipe structures to release air entrapped in the pipeline. There is a spelling mistake here, pipeline, and to prevent vacuum. Normally, these air vents, even in your house also, when water is supplied, air vents are seen with a small pipe rising from the connections, right? On the particularly on the floor, on the roof of your house. Entrapped air must be removed to permit an even flow and avoid danger of water hammer. So normally water hammer occurs and it will crash the pipeline at any point, particularly at the ends. So that will prevent, water hammer will be prevented. They are installed near the pump stand and at all high points in the line, at sharp turns, at points where there is a downward deflection of more than 10 degrees. So at all these points, these are first of all near the pump stand, and then all high points in the line and then sharp turns, right? So wherever this pressure they feel, they release that, okay, directly downstream from any structure that may entrap air and the end of the pipeline. So this is how where you have to install. Vents are generally installed at points about 150 meters apart. So each air vent to air vent distance is about 150 meters apart, and a straight pipeline. This is 150 meter distance only on the straight pipeline and with uniform slope. Gate stand may also substitute for air vent. Already we have told this point. The first air vent is located near the pump stand. We have seen the pump stand at the beginning. The first air vent immediately after pump stand, the next the air vent should be provided at a point where the design velocity exceeds 30 centimeters per second. Okay, when you are calculating velocity, this will be kept in mind. So where this exceeds 30 centimeters per second, you will provide a air vent. This occurs at a distance between 3 to 5 times the diameter of the pipe used. So that is a rough estimate. Okay, the area of the vent pipe is in contact with the pipeline should not be less than half of the area of the line. Suppose a pipe, it is in contact with the main pipeline, underground pipeline. So how much this air vent pipe should be? It should be less than the half of the area of the line. This can be further reduced until the area of the small pipe is not less than 1/6 of the area of the main line. So in no case the diameter of the small pipe, that means air vent, should be less than 5 centimeters. The vents should be high enough to provide a freeboard of at least 60 centimeters above the maximum height with the water will rise at that point. Suppose from the underground pipeline, the water will rise to some extent. From there onwards, you should provide 60 centimeters above that maximum height with the water rise. Okay, these are some of the points. This is how the air vents sectional view and then isometric view look like. This is a very simple one. This is the underground pipeline, and then vent is arranged here, and of course they are fitted. All those things, they are self-explanatory. Then the end plug. At the end of the pipeline, you must provide this end plug. There is a concrete block, concrete plug, then the mortar band. At the end of this underground irrigation pipe, you should provide. The dimensions are here. All these things. Basically, they are absorbed pressure developed at the end of the line due to water hammer. That is the thing. So whatever that water hammer that is developed due to various bends and then other structures, sudden release, even also to meet unexpected high pressure due to sudden openings or closing of the walls, this pressure develops. That is what we call as water hammer at the end. Unless we provide a strong base concrete plug, and the pipeline system may burst. This is the purpose. That is the purpose. So this is a riser pipe and valve. So wherever you want to draw the water from the underground pipeline, this is the one instrument. You will draw the water to the surface of the ground. So this is underground flow, and through this pipe arrangement it will rise, and there will be a valve. So you can simply unscrew that valve and then water will appear. The most common outlet consists of a concrete riser pipe to bring the water from the buried pipeline to the ground surface, and an attached valve to control the flow of water. So from the underground pipeline, if you want to draw the water to the field, this is the arrangement. This is the underground pipeline, and for which you will fitting a riser pipe and then a valve. Okay, this will prevent the entire flow. The diameter of the riser pipe is usually the same as the main pipe. This is the one thing. This will permit the entire flow of the pipeline to be released through the valve. In large size pipelines, when a number of outlets are to discharge water simultaneously, then the size of the riser pipe is smaller than the main pipe. It all depends on how much water you want to draw. Suppose you want to draw less than 1/2 of this flow of this total flow, then definitely your diameter of this size will be less. Okay, so that follows. This is how it looks like when a partially open riser valve, the water will flows to the field, right? So hydrants and gated pipes. Hydrants are devices placed over riser valve outlets as a means of connecting portable gated pipes to the pipeline. See, they are portable so that they can be moved from one valve outlet to another to serve the portion of the field which is being irrigated at time. For example, this is the riser we have seen, but we don't want water at this place. Suppose we want to carry water to some other place where you cannot carry this main line up to that, which may not be economical. What we do is, after riser, then you substitute with one other instrument called hydrant, where it will fix on the riser, and again this is fixed with a gated pipe. So this pipe on the surface it will run. This is, see how a portable hydrant installed on a riser valve as a means of connecting a portable gated pipe for water application. The farmer is seen inserting the gated pipe into the hydrant opening. So what are these hydrants and gated pipes? They are simply devices, and devices to draw the water from the riser, but the water which is drawn not to irrigate the field at that place, but they are devices to take that water to some place at a distance. So the first one is the hydrant. This is, see what you see in the figure, where it is fixed on the riser, and to this hydrant a gated pipe is fixed. So this pipe runs where do you want the water to be taken. So gated pipes are portable lines with uniformly spaced outlets used for releasing the irrigation water. So okay, as this pipeline is run, when you want to release, then you can release from that pipe. When connected to the buried pipelines through hydrants, they permit conveyance of water in an enclosed system from the source to head end of the irrigation pipe. So altogether, I think that is the end of the presentation, I suppose. Yes. So what I feel is we have seen the underground pipeline irrigation system in two videos. So one is stressing the need for underground pipeline irrigation system to save water, and then various elements, how each one of them, starting from pump stand, air vent, and then of course gated pipe, valve, and then riser, and then hydrant on which we fix, and then all these things. Okay, I will stop this video and we will continue with the next chapter. Thank you very much.